Hi everybody, in this video we will be verifying the trig identity you see on the screen right now. If you are seeing this video right after it uploads, that means that I'm still near the computer and I will see any comment you make. So if you make any requests in the comment section, I will try to record that video right away while I'm on the computer and I have everything set up and ready to go. So by all means, go to town on it. Okay. Here you have a trig identity in front of you. I'm going to kind of talk you through a little bit of what goes through my head for anybody that's like, I don't know where to start. I get overwhelmed and freaked out. I don't see it. I never see, what to do next. I never know where to start. It stresses me out. So first thing is I try, and there's no right or wrong answer here. Like you can verify these 100 million ways. You can get there eventually, but it's just a matter of efficiency, right? And are you kind of stumbling into the answer by accident, or is there more intentionality behind it? And are you able to kind of see the most efficient, organized way to get there and be done, or apply certain techniques that you're a little experienced with from other problems, from other examples? So when I look at this, I tend to take the messier side. So in this case, that's the left. I also tend to lean into, if I have a product on one side, pretend that was multiplying, and I have a sum or difference, I tend to manipulate the sum, usually, and it's not always, there's cases that things, could override that. But I tend to take the sum or difference and use that, find a common denominator to bring it together into one clump term, and then I would have gotten rid of that plus or minus sign in some capacity. I also tend to manipulate the side that has non-sine cosine things over the one that's already just sines and cosines, right? That I call panic mode. You're sort of decomposing everything down to its basic, it's ones and zeros, if you will, right? It's like binary code. So we're going to get everything down. This side has the non-sines and cosines. We have also, if I have an opportunity to clear out any complex, compound type fractions where you have fractions inside fractions, if I have an opportunity to clear those out and clean them up, I'm going to take that opportunity. Now, I hate that I'm doing this, but before we start, if you had something like 2/3 plus 7/2 over 5/4 minus 11/6. Okay. This here is a very loaded fraction. I have fractions inside fractions. Now, I know when I learned how to clean this up and simplify this and work it out into what it actually equals, I would say I probably learned to do this in the following way. I would find a common denominator on top, bring that together, find a common denominator on bottom, bring that together. Then you're allowed, only then are you allowed to do keep, change, flip, right? So just quickly here, I'd multiply 2 on top and bottom, you get 4/6, plus multiply 3 on top and bottom, you get 21/6 here. Now keep in mind, if you're doing this without a calculator and you suck at your times tables, it's going to be that much harder. So, just because I make it look easy doesn't mean it's going to be easy for you. No offense. 12 would be my lowest common denominator here, not 24. Come on, think smarter, not harder. Multiply on top and bottom by 3. That's going to be 15/12 minus multiply on top and bottom by 2, 22/12. Can't keep, change, flip yet, right? So add these. We have 25/6 over 15, take away 22 is -7/12. Now you could keep, change, flip, right? So you have 25/6 divided by that mess. So that becomes times 12/-7. Again, think smarter, not harder. Reduce this. Don't you dare multiply the 12 and 25 and the 6 and -7 and try to reduce it. That's for rookies. Don't be silly. So, and like if you had to, I think, what is that going to be? 300 over -42. That's annoying, right? And then reduce from there. Like, don't be ridiculous. Reduce now. So that becomes a 2, a 1. That's 50/-7. And we can just put that negative on top. So great. That's the answer. Is that terrible? No, it's not terrible. Is it going to be terrible when you suddenly have sines and cosines or exponentials and logs and all this other stuff? Yeah, it's going to be way more annoying. So what did I do? or what do I suggest you do? What is the lowest common denominator of 1, 2, 3, 4 parts? That would be 12. So I would multiply the entire top by 12, the entire bottom by 12. By doing that, I'm technically multiplying by 1, which is totally legal and allowed. I would distribute that. Do not write 24/3. You look like a dodo head. Like, that's so silly. You shouldn't have fractions inside your fraction while doing this. If you do, you're not doing this correctly, okay? Reduce as you go. PEMDAS is a lie. You can divide before you multiply. You could subtract before you add. 12/3 is 4. 4 times 2 is 8. Here, 12/2 is 6. 6 times 7 is 42. 12/4 is 3 times 5 is 15 minus 12/6 is 2 times 11, 22. That gives me 50/-7. Done. Same answer. So we're applying that to this problem in a moment. Okay? So here's the problem. I'm going to take this side. I'm going to clear out compound fractions, complex fractions. I'm going to find a common denominator if necessary. I also am anticipating, I see sine minus cosine, a lot of other stuff. I know the powers are likely going to go up, right? When I start cleaning this up, when I start multiplying on top and bottom. Will I end up with sine squared minus cosine squared? Because if I do and I reduce, sine squared minus cosine squared is the difference of two squares. That's going to be sine plus cosine, sine minus cosine. I could see a sine plus cosine coming from that, and you should be able to start seeing that too. So let's dig in. Sine theta over, I'm rewriting using quotient identity, 1 minus cosine theta over sine theta. Minus here, cosine theta over sine theta over cosine theta minus 1. Denominator of this guy is 1, 1, 1, and 1. What would be my lowest common denominator on my left fraction? That would be sine theta. So that's my 12 that I used a moment ago. Sine theta over sine theta. What's my lowest common denominator on this fraction? That would be cosine theta. So I multiply by cosine theta on top, on bottom. Now, when I multiply it through, distribute it in, I'm going to reduce as I go. Okay, sine times sine, sine squared theta. There's that sine squared I already mentioned for the difference of two squares, right? Over on bottom, sine theta is sine theta times 1 minus sine and sine reduce, and I'm left with cosine theta. Is that going to reduce and leave me with that sine plus cosine because I'm going to factor the difference of two squares? You don't reduce from sums and differences, okay? Minus, now cosine times cosine, cosine squared theta. The bottom, cosine over cosine goes away. I'm left with sine theta minus cosine theta. How wonderful, how convenient is this working out? So again, this equals that right side, sine theta plus cosine theta equals sine theta plus cosine theta. Maybe you just draw an arrow the whole way down. I think it's better for most people if they just leave that as the, leave that as on the side for a reminder, okay? Sorry, I'm trying to do this the best way. Okay, here we are, right? Let's carry on. Now they have a common denominator, so I'm just going to rewrite them together with the same fraction bar, right? That gives me sine squared theta minus cosine squared theta. This is exactly what I imagined would happen. Then the bottom is that common denominator. No, you don't write it twice. It's a common denominator. You write it once, you silly, silly goose. Now, if you give your teacher any indication that you thought reduce, 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 negative over negative, or minus over minus is plus, go right to jail. Goodbye. That is ridiculous. You can't, for the bazillionth time, reduce a fraction that by crossing things out from sums and differences. They have to be connected to the rest of the problem with multiplication, okay? So what does that mean? That means you're going to factor, okay? Factors are the things that make a product. So we're going to factor. That's, again, the difference of two squares, as I already alluded to. Sine theta minus cosine theta. I'm going to use conjugates to factor. Sine theta plus cosine theta. That's my numerator factored. I'm showing that, and I'm showing I have a clue, right? There we go. Equals sine theta plus cosine theta. Now we can reduce. Beautiful. Now you can, but that's a sum or difference. Yeah, but it's a factor. Also, do not forget, remind yourself every minute of your life that all numerators and denominators have an invisible parenthesis around it, okay? And if you have a minus sign in front of that whole fraction and you end up with just the numerator, you're going to have to distribute that minus sign to the entire numerator, okay? Obviously, a plus sign, nothing changes. Done. Verified. Sine theta plus cosine theta does, in fact, your last step should look like blank equals blank. Something equals itself. If you don't have a step that looks like this, well then, are you even finished? I would say no. That's the end of this example. I will upload this right now, and I'll be recording. I think this is like number 54. I'm gonna, I think, do 56. I already forget. Maybe it was 56, 58. Actually, I have it right here. Right, this was 54. I'm about to do 56. So again, leave a comment if you want me to do a different one. Question, comment, concern, requests, comment section, and check the playlist that this is a part of for more examples in case maybe I already recorded one. And if you get it, got it, good, great, then you could go ahead and give a little thumbs up on the video, perhaps, you know. And if you don't know what's happening, go ahead and give it a thumbs down. I have a thumbs down as well. Where's my thumbs down? Well, here it is, but it's stuck behind the screen. There it is. Okay, so there you go. And that's it. Bye. Adios.